This is writing linear equations, and this is part 3. So today we're going to learn 2 more types. You're familiar, this is standard form, but I'm going to show you some of the more unique problems that you might see. So if we have to write it in slope-intercept form, we remember slope-intercept form is y equals mx plus b. And we are isolating, we notice that y is isolated by itself. So when we look at this equation, we want to isolate y. So there are 2 things happening to the y at the moment. 3 is being multiplied by y, and 8x is being added to it. So we have to get rid of something being multiplied and something being added. And we always remember we want to get rid of things being added and subtracted first. So we need to get rid of this positive 8x. So we will subtract 8x from both sides. When these cancel, that leaves me with 3y on the left side, and on the right side will be negative 8x plus 15. Those are unlike terms, so we cannot combine 15 and negative 8x. And now we're close. Now we have to get rid of that 3 that is multiplying it, and the inverse of multiplying is dividing. And we remember that we have to do it to everything on that right side. So that cancels and leaves me with y, where negative 8x divided by 3 is negative 8/3 x, and positive 15 divided by 3 is positive 5. And we know that we've gotten our solution because we've isolated y. Y is by itself. There's nothing being added, subtracted, multiplied, or divided by that variable. And we like this. The reason why we want to get it in slope-intercept form is because we can pull those 2 pieces of information out. We can find the y-intercept, which is 5, and the slope, which is negative 8/3. So if we had to graph this, we could graph it quite easily. We can make 1, 2, 3, 4, 5. We can make a dot here, and then we can use the slope, go down 1, 2, 3, 4, 5, 6, 7, 8, and then right 3. And we've just been able to graph that line real quickly. So that's the benefits of putting it in slope-intercept form. You don't have to graph these. All I want you to be able to do is be able to convert that standard form equation, this initial problem right here, and I want to make sure that you are able to convert it into slope-intercept form. Let's look at the next problem. A little bit different, and we see, wow, there's only one variable here. Our objective still is to isolate y. We still want to get y by itself. We're going to ask what's happening to it. It's being multiplied by negative 3. The inverse of multiplying by negative 3 is dividing by negative 3. All too often, students will change the sign. We're not looking to change the sign with multiplication and division. So the inverse of multiplying by negative 3 is dividing by negative 3. And then we have negative 9 over negative 3, which gives me 3 equals y. And just for consistency, we're going to have the variable come first. Let's look at another one. Here we have only one variable. Remember, we're trying to isolate for y. What do we notice? Yeah, there's no y. So this is a very, very unique problem where there's only one variable, and in this case, we're going to just isolate x. This is the only time we will isolate for x is when there is no y to isolate. So we need to subtract 3 from both sides, and we get x equals negative 3. I know that's a little odd because there is no y that we're isolating for. So in this case, we're going to just isolate for x, and that would be x equals negative 3. Number 4 is, again, now we've got fractions. We have 2 variables. So when we have 2 variables, we know that we can isolate for y. And there's a lot of stuff going on here. So not only is y not by itself, but it has an x, and it also has the constant on that side too. So we can do a couple of things. I would, since instead of moving the x, whoops, that's not what I wanted to do. Instead of moving the x over and moving the 3/2 over, why don't I just, why don't I just move the y over? So if I can move that y over first and then get rid of its coefficient, that's going to save me a step. So my first step is actually going to be, I'm going to subtract 3/4 y from both sides. That will cancel it on the right side and place it on the left side. So we get negative 3/4 y. X is left on the right side, and 3/2 is left on the right side. I'm going to move this over a little bit. Now, y is not isolated yet. We have to get rid of that negative 3/4. That negative 3/4 is multiplying y. So I'm not going to divide by negative 3/4. That would be really, really difficult, right? If we have this, that would look kind of crazy. So in this case, we know that one way of isolating, or the inverse of multiplying, could be dividing. It's also the inverse of multiplying is multiplying by the reciprocal. So the reciprocal of negative 3/4 is negative 4/3. So I'm going to do that to both sides. And what I have to remember is I have to multiply it to x, and I have to multiply it to 3/2. So this is probably the most challenging problem today on this work that we're going to do. So x times negative 4/3 is negative 4/3 x. And then off to the side, I'm going to do 3/2 times negative 4/3. I can cancel these, and I can cancel this with a 2. So 3's cancel, and then 2 goes into negative 4, negative 2 times. So I have a 1 here and a 1 there. So 1 times negative 2 is negative 2. There's a 1 here also. And 1 times 1 gives me 1. So I'm multiplying across here, and I get negative 2 over 1, which is equal to negative 2. So now I've isolated my variable y, and that would be the equation in standard, or in slope-intercept form. Here is a problem for you to try. So take a moment. We're going to isolate for y. Take a second and go ahead and do the work on a notebook. And when you're ready, you can hit unpause. So in this answer, I gotta get my y by itself. Again, this is a unique one because I have my x and my constant here. So to make it easier, I would just move the 3y across. And we're left with 5x plus 6 equals 3y. Some of you maybe moved the x and the constant over. If you did that, copy, paste. If you did that, if you subtracted 5x, you got 6 minus 3y equals negative 5x, and then subtracted 6, you get negative 3y equals negative 5x minus 6. A little bit different from this equation over here, but we'll still get the same answer. So that's why this moving the y first is so much more efficient. So we have y by itself, we just have to get rid of its coefficient. So in the left problem, we would have to divide everything by 3, which would give me 5/3 x plus 2 equals y, or y equals 5/3 x plus 2. And then on the right side, we would have to divide by negative 3. And that would give me y equals, 2 negatives make a positive. and two negatives make a positive. Same equation, same problem, same answer. Just two different ways of going about it. The left way is going to be more efficient. Now, what if we get it in point slope form? So our objective is still to get y by itself, but we notice on the right side we actually have some work to do. There's a distribution property that we have to do. So before I start isolating for y, I'm going to distribute that 2 into both of the terms. So I'm going to simplify that distribution, which gives me 2x plus 8. Now I'm going to get y by itself. 3 is being subtracted. The inverse of subtracting 3 is adding 3. Notice I only do it once to the left side, once to the right side. A little bit different than multiplication and division. We're only going to do it once on the left side and once on the right side. So that leaves me with y equals 2x plus 11. And notice that I put this positive 3 under the constant, like terms with like terms. So my answer is y equals 2x plus 11. Let's take a look at another one. Again, our objective is to get y by itself, but on the right side, I got a distribution that I have to do. So I have to distribute that 7/5 into the parentheses. So I would have y equals y minus 4 equals 7/5 times x plus 7/5 times negative 5. Don't forget that negative. That negative is attached to the 5, not the 7/5. Y minus 4 equals 7/5 times x is 7/5 x. 7/5 times negative 5, that 5 is in the denominator, this 5 is in the numerator, so that becomes 1, and then we have 7 times negative 1, which is negative 7. We're going to now be able to isolate the variable. I'll add 4 to both sides. Y equals 7/5 x minus 3. Good. And here's your problem to try. So take a look at this problem. Remember the steps that you'll need to do first, distribution and then isolating, and pause it, work on it, and then when you have your answer, unpause it. All right, so we're going to distribute the negative 3 into the parentheses. That will give us y plus 2 equals negative 3 times x minus 3 times 1. We're distributing a negative 3, so I want to see that negative attached to the 3. Let's simplify the right side. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. And now we can get y alone. 2 is being added to it. So I'm going to do the inverse of adding 2, which is subtracting. And remember, I only do it to one side, to one of the things on each side. And my final answer is y equals negative 3x minus 5. Hopefully that helps. Take a look at the worksheet. Don't forget to fill out the exit slip. And if you have questions, come and see me during office hours on Zoom. Thanks.